Hello everyone. If you haven't already figured out the mistake which I made with the AND example in the previous lecture, let me explain it to you. I was showing you how to extract the numbers less than 12 or greater than 33 from a series S using this particular example. I changed the OR to an AND. That particular example does not make any mathematical sense because you cannot have a number both less than 12 and greater than 33. Instead, I meant to show you this example which enables us to extract the numbers in between 12 and 33 from the series S. Please pause the lecture video here and download the template notebook file for today's lecture along with imdb-movie-data.csv file. We'll be using this CSV dataset during the later part of today's lecture. Let's get started by reviewing data alignment. I didn't quite use the term data alignment in the previous lecture. It just refers to the fact that when you apply a specific operator element-wise between two series, Pandas lines up the values within those series based on index matching and not integer possession matching. Let's do a quick recap of the terms index and integer possession. Every value within Pandas series will be associated with two labels. Index in Pandas series can be thought of to be equivalent as keys within Python dictionary. Integer possession in Pandas series is going to be equivalent to index within Python list. Integer possessions are going to be 0, 1, 2, etc. for the values. Let's look at the import statements here. The first statement is importing pandas module with the abbreviation as PD. Then I'm using the from style of import to import series and data frame from the pandas module. I'm doing this explicitly so that I don't have to keep typing pd.series and pd.dataframe for every single example. I'm still retaining the import style of import so that we can use PD to access other functions within the pandas module. We'll be going through a series of questions based on this particular example to review the concept of data alignment. I'm creating three series. Each of those series is getting created from a Python dictionary. All the Python dictionaries have two keys as strings A and B. Let's review index and integer possession using series X and series S2. The value 10 within series X is going to have an index A, which is coming from the Python dictionary key, and the integer possession is going to be 0. The value 100 is going to have an index B and an integer possession of 1. The value 3 within series S2 is going to have an index of B and an integer possession of 0. The value 2 within series S2 is going to have an index of A and integer possession of 1. Let's answer this first question over here, which is asking what is X into S1. Let me go ahead and display X and S1. Recall that we can compute X into S1 simply by typing X into S1. In this particular example, there is no need for data alignment. That's because the index and the integer possessions within the series X and S1 match without any sort of ambiguity. So you're going to end up with a value of 20, which is 10 into 2, and then a value of 300, which is 100 into 3, and the index will be A for 20 and B for 300. Let's go through the next question, which is asking what is X into S2. In this particular example, there is a need for data alignment. That's because there is ambiguity with respect to matching up the values based on index or integer possession. The value 10 is going to have an index of A and an integer possession of 0. The value 3 is going to have an index of B but an integer possession of 0. You'll always be lining up the values based on index. So you're going to end up with 10 into 2 because the value 2 within series S2 has an index of A and the value 10 within series X has an index of A. Similarly, you're going to end up with 100 into 3 and the corresponding labels are going to be A and B for the values 20 and 300 here. The next question is asking what is x less than s1. Let me go ahead and type the expression over here by saying x less than s1. You're going to get a Boolean series which has the values of false and false, because none of the values within the series x is lesser than the values within the series s1 over here. Let's compute x less than s2. This is going to cause a problem here. Let me go ahead and show you the error that you will get. You'll end up getting value error because unfortunately Pandas folks couldn't figure out how to implement data alignment for the comparison operators due to restrictions in Python. Instead of allowing people to use the less than greater than comparison operators for comparing two different series which have alignment problem, Pandas created support for LT and other kinds of abbreviations for the other comparison operators. Let's go ahead and try x dot lt of s2. That's going to enable us to get the correct Boolean series over here which returns false and false, because the x series values are not lesser than the s2 series values over here. Let me fix the display really quickly. That does not make much difference actually, because s1 and s2 have the same set of values. How would we apply greater than? We are just going to take this particular example and replace LT with GT. That's going to flip the Boolean values to both true, because the values within X series will be greater than the values within S2 series over here. What about equal comparison? We can use EQ to determine whether the values are equal. You're going to end up getting false and false, because clearly the values in the series X are not equal to the values in the series S2. Let's go through the last three examples here, which is saying greater than or equal to. I'll let you go through the result over here. I'm going to show you how to do less than or equal to. That's going to be LE. Once again, I'll let you go through the result here to confirm whether this is the correct answer. The last operation that I want to show you is the not equal to, which is going to be NE. You're going to end up getting true and true for not equal to, because clearly the values are not equal between those two series. The key thing for you to remember with respect to data alignment is that you cannot apply comparison operators between two series whose data is not aligned properly because of mismatch between integer position and index. Instead, you have to use these operations which have LE or GE and other kinds of abbreviations. These should be pretty straightforward for you to remember. Let's look at how we can fix the ordering within the S2 series so that we can avoid having misaligned series for the comparison. We are going to use the sort underscore index function within pandas series. I'm going to go ahead and sort the values within S2 series based on index. Let me capture the return value into a variable called sorted underscore S2. This particular function is going to return a brand new series object instance which has the values sorted based on the index sorting. So you're going to end up getting 2 first, which has the index of A, and you're going to end up getting 3 first, which has the index of B. Let me go ahead and display S2 really quickly here so that you can look at the difference between sorted underscore S2 and S2. Let me go ahead and fix the parenthesis. There you go. The original series has the values is 3 first and 2 next. The sorted series has the values is 2 first and 3 next. How can we now overcome the data alignment issue? Now it should be very easy for us to compare sorted S2 and X. For example, I can say sorted underscore S2 greater than X. Let me go ahead and display X here. Sorted underscore S2 is not having values greater than X. So you're going to end up with a Boolean series of false and false over here. I'll wrap up this video. In the next video, we are going to learn about data frame.